And this first example is one involving population size. Functions arise whenever one quantity depends on another. And the easiest way I find to think about functions and to understand functions are to think of them as little machines that have inputs and outputs. They're an input-output machine. So in this particular example here, we've got a table where on the leftmost column is year from 1900 through to 2010, and in the column beside that is the world population size in millions. Now we can think of the population size as depending on the year, and so our function here would be a function p that takes as its input the year and gives as an output the population size. So for example, if I wanted to know the population size in 1950, I just look in the first column for the input value 1950, and then I'd read across in the second column the output value 2,560,000,000 people. Now notationally what we would do is usually write this as P evaluated at the input value 1950 is equal to the output value 2,560,000,000. Here's another example. This is an example involving an electrocardiogram, which is a measurement of the voltage produced by your heart on the surface of your body in a particular direction. Now this function is given graphically. We've got voltage on the vertical axis here and time on the horizontal axis. And again, we can think of this graph as giving us a little input-output function. The inputs are different possible values of time in seconds, and the outputs are different voltages in millivolts here. And so we would say that the voltage is a function of time. And again, we might use the notation V evaluated at some point, for example 1, time 1 in seconds, is approximately equal to 0 in this case.